Okay, so looking at these statements, we decided, are they true or are they false? So right now I'm in math class and English class. Okay, so y'all say false. Okay. B, right now I am in math class or English class. Okay. 3 plus 5 equals 8, and 5 is less than 6. True, okay. 10 plus 2 is not equal to 12, and 8 minus 3, which is 5, is greater than 0. Okay. 3 is less than 9, or 10 equals 9. Okay. And then negative 4 is greater than 1, or 5 plus 5 plus 4.5 is 11. Okay. So talk to me about how you chose true or false. How did you choose true or false? Was there something that gave you a clue? Something had to have given you a clue.
Whoa, wait, that's weird. It's and or.
What do you mean?
The things say, like, they switch it up.
Okay, so you notice that in some statements there were and, in some statements there were or. So looking at G, it says, if it said and, what did you realize about the statement that you did naturally? So what has to happen for and to be true? Both. Okay, so both have to be true for and to be a true statement. All right, so when you saw or, what did you realize? Only one has to be true. Now, you did that naturally. I didn't teach you that. You know that just from the English language. So let's talk about what happens when we apply and or in math. So turn the page. So look at the first 4 examples on S88. So first of all, they call them systems. Let's not get frantic about that. I'm not having you do elimination and substitution, okay? It just means that there's 2 either equations or inequalities that we're gonna be solving or using within a problem, okay? So look at the first one. What do you have? You have an or, and what do you notice about the 2 statements? They both have equal signs. So are we talking about those rules, or are we talking about these rules? These rules. So it's very important today as we're going through, if you see equal signs, that you know you're talking about the equation rules. If you see greater than less than signs, you know we're talking about inequality rules, okay? 2 completely different sets of rules. So it tells us to solve them. So let's go ahead and solve them. And I should be able to do this in my head. X equals negative 5 and X equals 8. Now, I have my 2 solutions. I have 2 ways that I can write it. The first way that I can write it is I can use the word or in between both answers, and that gives me a correct statement. The second way that I can write it is I can write it as what's called a solution set and list both of them with a comma in between braces. Why am I using braces and not parentheses? What if I change that to parentheses? What would it look like? A coordinate. Is this graphing? No. These are answers. So that's why when you create a solution set as an answer, it has to be in braces. So if you can't draw actual braces, just use squiggle lines so that you know it's not parentheses. Okay, so that one was pretty easy, but what about the second one? Do you notice the verbal statement is an or? And you have 2 equations. Can you solve them? Go ahead and solve them for me. Okay, so after you solve them, write the 2 ways that you can write the answer for me. okay? So you should have put or in between the two answers, or you should have did a squiggle, 9/4, comma, -1 with another squiggle. Did everybody get that right? Thumbs up. Not everybody?
No, we didn't go there.
How did you not go that fast? These are two-step equations from 7th grade. You should be able to solve them pretty quickly. Okay, most of it should be in your head. Okay, so the only thing you had to make sure that you did was that you made sure you put or between the two statements, or that you wrote it in a solution set with braces. Okay, look at C. What's different about C from A and B? You have and now. So and means that both of them have to be correct for it to be a true statement. So go ahead and solve them both. Should be able to do it in your head. Are they both true? Yes. So let's write this as a solution set. So I can put the word and in between, or I can do a squiggle with just the number 7. And that's correct. That is a true statement because they both are equal the same amount. All right, D. Now D, what's different about that problem? One's an equation, one's an inequality. Guys, it is so critical that in these problems you can see if something's an equation or something's an inequality, because that's going to direct you on how you act. So I'm going to solve this one first. So I do +8, and I get 2w equals 18. So what's my answer? 9. We should be able to solve that. And then I can rewrite my inequality. So is that true? Because it's an and statement, so both of them have to be right. Is w equal to 9 and w is greater than 9? What would have to be there to make it true? A line underneath the greater than symbol. So what we do to represent this answer is we put a 0 with a line through it. That is the symbol for empty set. So there is no solution. You write empty set, and that symbol, the circle with the line through it, is the symbol for empty set. So now let's take it a little bit further, because if we're solving two inequalities or two equations at one time, we're going to have to be able to graph them both at one time, okay? And so we're going to talk about what happens when we have to graph them and they have two variables. That's going to be graphing on a coordinate grid. But right now, we're talking about just basic one variable equations that we solve and we graph on a number line. So one of the ways they do this with like a lot of traditional students is they get two colored pencils and they see how the colored pencils react to each other. I don't need you to do that. You're going to pick it up on the first example. It's that easy, okay? So look at the first one. It says, graph the inequality x is less than 3. So everybody do that. X is less than 3. We're going to be doing a lot of graphing in the next couple examples. I need your pencil in hand, ready to graph. So I go to 3, open or closed, open, less than, it goes in this direction. So then I go to the second one they give us, and they say x is greater than -1. So I go to -1, and it's greater than. It's in this direction. What do you just notice happen?
Yeah, they just met up.
They just meet up. They're connected. That's because the answer has to be between here and here. That is an and statement. They connect. Your answer can only be between that point and that point. That's why it's an and statement. So what's the other word we learned? Or. Let's see what that looks like. So we go here and we graph x is less than -4. So I go to -4 and it's less than. And then the second one is x is greater than 0. I go to 0 and it's greater than. What did you just notice? I call them angel wings. Here's the good trick. When you have an or statement, they have to use the word or. So if you don't see the word or, then you know they're going to connect. If you do see the word or, they're going to look like angel wings. So let's put that into play now. Go to the next example. It says graph the compound sentence. Compound, let's talk about that. We know compound words.
Yeah.
right? Witchcraft, that's 2 words put together to make one. We were joking last hour, Dalen, Day, and Lynn, because those are 2 names put together to make one name. I know, we came up with that. Minecraft is also 2 words put together to make the title of the game. Compound words, 2 expressions or equations or inequalities put together to make one statement. That is a compound inequality, okay? So looking at this, let's see what we decide. Is this an and or an or? So we've got greater than -2, all right? So I'm gonna do that. Open circle, greater than. We know how to do that. And then the second says x is -2. That means I just gotta fill in this hole because -2 counts. Is there a better way to write that, you think? Ashley's got an idea. What did you say? We could just do this, guys. We can make it equal to. It is the same thing as this in one statement. So if we look at the next example, it says, how could we rewrite x is less than or equal to 4 in 2 statements? How could we rewrite that? X is less than 4, and x is equal to 4. Because if we still graphed it, it would be a closed circle, and it would be less than. But it would be a more clearer, concise way to write it. Independently, I want you to do A and B. They're both or statements. Go ahead and graph those for me. Remember, an or statement's easy because it has the word or in the problem. Should be wrapping it up on number 2, or letter B, I should say. Do they connect? No, they shouldn't, because one is true and one is not. Remember, only one has to be true. When it is an or statement, they are not going to connect. They're not going to overlap. So the first one, you should have a dot at 2. That's an equation. Equations don't have lines. They have one specific answer. And then, of course, this was a typo. You just had to extend the line to 6, and it's open at a greater than. And it looks like this on my graph. For my second one, it's a little bit clearer because the graph is actually there. I've got -5 that's closed, and it's less than, so it goes to the left. And I've got 2 that's closed, and it goes to the right. See the angel wings? But if it's got that or, you automatically know it's angel wings, and you don't have to sit there and be really crazy with the graphing. But look at C. What is different about C? It's connected. And look, it's still a compound sentence, but it's saying, hey, use X for this inequality and use X for this inequality. So what I tell my students to do is cover this one. There's your first one. Then cover this side. There's your second one. So when I cover the first one, I get this. When I cover the second one, I get this. And now I have them both separated. I'm not worried about it being read backwards like this because I know how to read it, and you should too. But if I wanted to turn it around, I would look at what is the symbol doing to the X? Eating it. So that means that I have to make it eat it in the other direction as well. Okay? I hate saying that, but doesn't it help you remember? Like, that's why I say it every time. So now if I want to graph it, let's see what happens on the graph. So I go to 1 and I put a dot. And it says that it's greater than, and then I go to 3 and it's less than, and look what just happened. And when it combines like that, I kind of knew that before I solved it, because what word did it not have? Or. So when it doesn't have or, and it's a compound statement written like this, then it's an and statement. And so I don't graph the line at the beginning. I put the dots and then just connect it because I know they're going to connect. It's an and statement. When you get problems like this, those rules apply. It's when you get problems like the next two, when they're put in real life scenario, that you have to use common sense when you're doing it. So look at the first one. I'm going to read it out loud while you read it silently. Students are to present a persuasive speech in English class. The guidelines state that the speech must be at least 7 minutes, but not exceed 12. So talk to me about what Ms. Ford wants you to do. Can you have a 7-minute speech? Yes. Can you have a 12-minute speech? Can you have something in between? Is that an and or an or? It's an and, because you can have anything in the middle. So let's talk about how to write this. Put your X. Start with the 7. The X must be bigger. So how do I say that with inequalities? Greater than, can it be 7? So I can put a line underneath it, 7. But then X must be less than, can it be equal to? Yes, 12. So when I graph it, I'm just going to put a 7, I'm going to put a 12, I'm going to put 2 closed circles, and they're going to connect because I know that my speech has to be between 7 and 12 minutes. Is that correct? See how I use common sense to kind of make that decision? Can it just be 7? Yes. Can it be just 12? Yes. But it's got to fall between those two. So look at the second one. Movie tickets are cheaper for children and senior citizens. To receive the discount, a person must be between 2 and 12. Why don't they have 0 and 1? You're a baby. You don't bring a baby to the movie. I've done it once. I was scared out of my mind. I went at 10 a.m. to a movie that had been out for weeks, and me and my friend were in there by ourselves, so it was okay if Julie started crying. But I wanted to go to the movie so bad. So you don't pay for a baby. Babies get in for free. So you pay a discount for between 2 and 12, and then if you're 60 or over. So is this going to be an and or an or? Do you get a discount in the middle? No. You get a discount if you go this way, and you get a discount if you go this way, but not in the middle. So we write our or, because we know for or statements, we got to write the word or. And so X must be less than or equal to 12. Now, technically, I could have wrote the X in the middle, and it would have been greater than or equal to 2, less than or equal to 12, but I'm not getting that technical yet with you, okay? So I just wrote X is less than 12, because to be honest with you, 0 and 1, they're not going to pay. And so then, or it could be X is greater than or equal to 60, because can you get in at 60 at the cheaper rate? Yes. So then graphing it, we've got a 12, we got a 60, we've got a closed circle, we've got a closed circle, and we have angel wings because it's an or statement. Okay, look at exercise 4. We're going to determine if it's true or false. We're not going to actually solve these because I'm going to be honest with you, these are baby problems. These are not 9th grade problems. None of them are requiring you to solve. They're just giving it to you so you can practice graphing it. So tell me on A, is that going to be connected or angel wings? Connected. Why? And. Very good. B, angel wings. C, bump. That's wrong.
Oh yeah, no, it's or, so it's
Bump. That's wrong. Anybody? What do you notice about C? They're both equal. These are equations. So your answer is going to be 9 and negative 15. So you're basically going to have 9 and negative 15 on the graph, and you're just going to have 2 dots on it. You're not going to be graphing anything with lines. You've got to catch it because they're going to mix them up. So look at D. What do you have? two equations. All right, so go to S91 at the top. E, compound, angel or not? Angel. F, not. It's going to be and. Go ahead and separate F for me and make sure you can separate it into two statements. Separate F for me into two statements. Check your work. Make sure it looks like this. If you flipped it around, it should look like that. Thumbs up if you got it right. Okay, good. All right, look at G and H, what they're asking us to do. So now we're going backwards. Now they gave us the actual graphed answer, and we got to come back with the inequality. I'm going to show you how easy it is. I'm going to use those rules to pinpoint what I see. So first of all, because it's connected, what do I know? And. So I'm going to put an X in the middle. Now, my two numbers are going to be -3 and 4. How do I know that? That's the two that are dotted. I also know that I'm going to have a line under each one, correct? Why? They're filled in circles. Now, 3 goes up, so that's greater than, and 4 goes down, that's less than. And I've written my compound inequality. So now do H for me. And or. Or, so that means you got to have the word or in the middle. Okay? Write it for me. So this one's easy because I know that I'm just going to write two statements. So X is less than, or is that less than or equal to? No, it's open. So it doesn't have a line, -4. And X is greater than 0. And there you have it. Easy. Turn the page. We're moving quick. All right, so just kind of sum up what we did, because these have been easy problems. If and is true, then both sides are true. If or is true, only one has to be true. Circle the following problems: 2, 3, 4, 5, and 6. I'm asking you tonight to just write those inequalities. It's just vocab, very easy. I'm not asking you to do 7 through 12 because those are baby problems. I'm gonna assign you some 9th grade ones in a minute. Rip that out, put it to the side.